In this section, we're going to focus on reflection for square root. So first, we're going to start off with a little review, comparing it with absolute value and quadratic. So in example 7, I have two functions, g of x, where it's written in absolute value form, and then h of x, where it's written in quadratic form, x squared. So if you were to look closely at these two examples, you see how we have the negative sign. And again, when you have a negative sign, you're dealing with reflection. So since we have a negative sign that's outside a function, meaning outside the absolute value lines, or outside the parenthesis, over here we have invisible parenthesis. So basically means that the negative is outside the function. So since it's outside, this is going to be a reflected across the x-axis. So again, here, if you look closely, this is our negative sign that's outside the function, hence reflect across the x-axis. Now looking at example 8, here I have two functions, n of x and p of x. N of x is written in absolute value form, and then p of x is written in quadratic form. Now here you can clearly see that the negative sign is inside the function, inside the absolute value lines, inside the outer parenthesis, and they're both in front of x. So this one will be reflected across the y-axis right here. And again, is based on this negative sign that we have right here that's inside the absolute value line and inside the outer parenthesis and in front of x. So when you have a problem like this and you're identifying, you're going to say reflected across the y-axis. Moving on to example 9, we have m of x equals to negative square root of x plus 2. So we're going to have a translation. We're just going to do a little practice with translation. But since we have a negative sign that is outside the square root, so this is going to be a reflection across the x-axis, and the plus 2, since it's inside behind the x, this is going to be translated left 2 units. So here's the negative sign. So that's why we have reflected across the x-axis, and then the plus 2 inside the square root and behind the x. That's why we're going to say translate left 2 units. Now moving on to example 10, we have w of x equals the square root of negative of x minus 5. So here you can clearly see that the negative sign is inside the square root and in front of x. So this one will be reflected across the y-axis. And again, since we have a number with the x that's behind x, we want to keep the minus 5 intact. Hence, we have a set of parentheses inside, because we don't want this negative sign to mess with the minus 5. If it does mess with the minus 5, it could change it into a positive 5, and therefore we won't get the right transformation. So we want to keep the minus 5 intact, so that way you can properly identify the correct transformation. So for this example, the minus 5, meaning that since it's inside behind the x, is going to translate right 5 units. So again, the negative that's inside the square root in front of x is reflected across the y-axis, and then the minus 5 that's inside behind the x is translated right 5 units. And as I stated before, we want the negative sign to be separate from the minus 5. If you distribute the negative to the minus 5, that's going to become a plus 5. So that's similar to this plus 2 here, and you would say translate left 2 units. But if you were to plot the graph or plot the function, it's going to be very different when the graph is going to move right 5 units, but you say left 5 units. So hence the importance of having a parenthesis to separate the negative sign away from the number that's with the x. So be extra careful when it's coming to identifying with the transformation with a negative that's inside and where you have a number with the x.